Hello everyone, welcome to our channel GEMLABs. In part 3 video, we have gone through software installation of Proteus, Arduino IDE and Arduino Uno library and real-time examples of Arduino. In this video, you will learn about sensor library installation, interfacing of 16x2 LCD display with Arduino, installation of IR sensor library in Proteus, object counting, automatic street light controller and programming concepts. Let us see interfacing 16x2 LCD display with Arduino. In part 1, we have already discussed about what is LCD display, real-time applications of LCD display. Now we are going to see interfacing of it. 16x2 LCD display consists of 8 data pins, D0 to D7, which is used to send data to microcontroller. Enable pin E, which is used for data acknowledgement. Read-write pin RW, which is used to read and write data. Basically, it is grounded if we want to write data to LCD. Register select pin RS, which is used to shift between command or data register. VSS pin is connected to ground. VDD pin is used to power up LCD. It also has 2 pins A and K used for LED. Coming to code, #include is used to include outside libraries to your sketch that gives access to the pre-made functions and also libraries written especially for Arduino for LCD display. We are having predefined library called Liquid Crystal. This library allows Arduino board to control LCD display. Using this library, we can work either in 4-bit mode or 8-bit mode. Here we have written code for 4-bit mode. Liquid Crystal LCD is a function used to define the object name LCD of class Liquid Crystal. Void setup is a function where we can initialize variables, pin modes, etc. The setup function will run only once after power up or reset of Arduino board. LCD.begin is a function where we can define number of rows and columns the LCD have. Here we have defined 16 columns and 2 rows. After execution of setup function, void loop is initiated. This function will be executed continuously. LCD.setCursor is a function that positions the cursor of LCD. If it is 0, 0, then cursor positions to first row. If it is 0, 1, then the cursor positions to second row. LCD.print is a function used to print data on 16x2 LCD display. Here we are going to print welcome and GEMLABs in LCD display. Now let us see interfacing of 16x2 LCD display using Proteus. First, go to Proteus software and select schematic capture and select P to pick required devices. In keyword block, type Uno so that it will show Arduino Uno. Double click on it, then it will get selected. After that, erase the Uno and type LCD. You can see the list of LCD displays in that. Select 16x2 alphanumeric LCD. After that, select Arduino Uno and place it in required location. After that, select LCD and place it in required location. Now start giving connections to Arduino and LCD display. Connect 0th pin of Arduino to D7 of LCD, 1st pin of Arduino to D6 of LCD, 2nd to D5 of LCD, 3rd pin to D4 of LCD, 4th pin to enable pin of LCD and 5th pin to register select pin of LCD. Now go to terminal mode and select ground and place it in the required field and connect VCC and read-write pin of LCD to ground. Now go to Arduino IDE software and write code for LCD 16x2 LCD display. After that, compile the sketch. After completion of compilation, copy the hex file. After that, go to Proteus software and double click on Arduino and paste the copied hex file in program file of Arduino and run the simulation so that it will display welcome in first row of LCD and GEMLABs in second row. After completion, click on Stop the simulation. Next one is object counting. We are doing this experiment using IR sensor. The objective of this project is to count number of objects, goods or product in industrial sector and counting people traversing in certain passage or entrance in commercial buildings, etc. IR sensor is a device used to detect objects in its surroundings. If you look at IR sensor, it consists of two LEDs that are IR transmitter and IR receiver. The LED which is in white color is IR transmitter and black colored LED is IR receiver. IR transmitter emits radiation in the frequency range of infrared, which is not visible to human eye. IR receiver is capable of detecting infrared radiation emitted from the IR transmitter. The operation of IR sensor is when IR transmitter sends infrared signal. If there is an object in its surroundings, then the infrared signal reflects back to IR receiver so that it captures the signal detecting the object. If there is no object in its surrounding of IR transmitter, the IR signal won't reflect back to IR receiver. So it results that there is no object. Coming to pin specifications, IR sensor consists of 3 pins: GND, VCC and out. GND pin is connected to ground and VCC pin is used to provide power supply and out pin is connected to microcontroller. Coming to working of object counting, when IR sensor detects an object, LED starts glowing and starts incrementing the count. If object is not detected, the LED stops glowing and the count value won't be incremented. Now let us see installing IR sensor library. First, go to Google Chrome and search for infrared sensor library for Proteus and select infrared sensor library for Proteus, the engineering projects, and scroll down so that you can see download infrared sensor library for Proteus option. Click on that and wait for some time. Again, it will show download infrared sensor library for Proteus and save the file in proper path in your PC. After completion of download, open the path where you have saved the IR sensor library file. In that, select infrared sensor library for Proteus and copy the hex, IDX and LIB files of IR sensor and go to local disk C and select program data. In that, select Lab Center Electronics. In that, select Proteus 8 Professional. In that, select library and paste the copied files of IR sensor. Follow the same process for installing libraries for remaining sensors like PIR, ultrasonic sensor, etc. Coming to code for object counting, int is a data type used to store 16-bit value. Here IR, LED are variables of int data type. We have assigned 4 to IR, which means 4th pin of Arduino is connected to output of IR sensor. In the same way for LED also. And counter is a variable of int data type and is initialized to 0. Pin mode is a function to configure specific pin to behave either as input or output. Here we are making IR sensor pin to behave as input and LED pin to behave as output. We have command called serial.begin. This starts serial communication so that the Arduino can send commands through the USB connection. The value 9600 is called the baud rate of the connection. Digital write is a function used to read the value from a specific digital pin, either high or low. Here, status sensor is a variable of int data type assigned with digital read of IR. If condition checks for condition and executes a set of statements if condition is true. Here we have given condition as if IR sensor status is equal to low, then it will execute the following statements. Serial.println is a function that prints data to serial port as human readable text and prints data in new line. Here it is going to print object detected in serial port. Digital write is a function that write a high or low value to a digital pin. When if condition is true, then LED starts glowing and count value will be incremented and going to print object detected and value of counter. When if condition is false, then else condition will be executed and LED stops glowing and prints object not detected. Let us see interfacing and upload code for object counting. Go to Proteus software and select schematic capture. In that, select P for selecting devices. In keyword block type UNO. It will show Arduino UNO and double click on it so that it gets selected. After that, erase UNO and type IR and select IR obstacle sensor. After that, type logic state and select logic state source. Logic state indicators are used to show the digital input given to them is high or low. Now type LED. It will show list of LEDs available in this. In that, select animated LED module yellow. Then type resistor and select generic resistor. Now select Arduino and place it in required location. In the same way, select IR sensor and remaining components and place them in required location. Now connect 13th pin of Arduino to resistor terminal and connect another terminal of resistor to LED terminal. Now change the value of resistance. After that, connect 4th pin of Arduino to output pin of IR sensor. Now go to terminal mode and select ground and connect LED cathode terminal to ground and connect ground pin of IR sensor to ground. Now select power in terminal mode and connect it near VCC pin of IR sensor. Now go to instruments and select virtual terminal. Virtual terminal is used to display data coming over the serial port of Arduino microcontroller. Connect pin 1 of Arduino to RDX pin of virtual terminal and pin 0 of Arduino to TXT pin of virtual terminal. Now double click on IR sensor and upload the hex file of IR sensor in program file of IR sensor. Go to Arduino IDE and write code for object counting. After completion of writing, compile the code. After completion of compiling, copy the hex file and go to Proteus software and double click on Arduino and paste the copied hex file in program file of Arduino. Now run the code so that when logic state is 0, LED starts glowing and prints object detected and increments the count value in virtual terminal. When logic state is 1, LED stops blinking and prints object not detected in virtual terminal. After checking the output, stop the simulation. Next one is automatic streetlight controller. We are going to do this experiment using LDR sensor. The objective of this project is to provide automatic control of street lamps. The street light system checks whether street lamp is on or off and checks whether light intensity is less or more using LDR sensor. LDR is a special type of resistor that reacts to change in light level. LDR is also called as photoresistor. The resistance of LDR changes as different amounts of light fall on the top of the device. This allows electronic circuits to measure changes in light level. Generally, they are used as light sensors. In this experiment, we are going to see when light level is low, then LED starts glowing, and when light level is high, LED stops glowing. We are going to do this by using LDR. Coming to code, we have initialized an LDR to analog pin of Arduino because LDR is analog sensor, and LED to third pin of Arduino, and in pin mode we have made LDR as input and LED as output, and taken LDR value variable of int data type and assigned with analog read of LDR. Analog read is a function used to read the values from the specified analog pin. In if statement, given condition as if LDR value is less than 200, and if this condition is true, LED will start glowing. If this condition is false, the else part will be executed and LED stops glowing. Let us see how to interface and upload code for automatic streetlight controller. First, go to Proteus software and select schematic capture and select P for picking required devices. In keyword block, type Uno and double click on Arduino Uno. Again, type LDR and select Torch LDR. After that, type LED and select Animated LED Module Yellow and type Resistor and select Generic resistor. Now place Arduino, LED, LDR and resistor in required location. Now connect one terminal of LDR to resistor and connect it to analog pin A0 of Arduino, and connect third pin of Arduino to resistor terminal and connect another terminal of resistor to LED and change the value of resistor. Now go to terminal mode and select power and connect it to LDR another terminal. Select ground and connect LED cathode terminal and resistor near LDR to ground. Now go to instruments and select virtual terminal and connect pin 0 of Arduino to TXT pin of virtual terminal and pin 1 to RXT pin of virtual terminal. After completion of giving connections, go to Arduino IDE and write code for automatic streetlight controller. After compilation of writing code, compile the code. After compilation, copy the hex file and paste it in program file of Arduino and click on run the simulation so that when intensity of LDR is below 200, the LED will be in on state. When the intensity of LDR is above 200, the LED stops glowing. After checking the output, click on Stop Simulation. In next video, we are going to discuss about motor interfacing and about freezing software. If you have any questions, you can contact with the details provided, and please do like, share and subscribe our YouTube channel. Thank you.